Alright, here's our proton. I'm going to put a positive plate behind it so that it wants to get away from that. It's going to feel a force directed to the right. And it's, of course, in a uniform electric field. 600 newtons per coulomb. Now it starts off with VI equals 0, but later its V final is 1,300,000 meters per second. And it's still feeling the force. The black vector represents the force that it's feeling, the red vector represents its velocity. Okay, we want the acceleration of the proton, so first formula I would use is F equals Q times E. If we know the field strength and the charge of the particle, then we can find the force that it'll feel. So let's do that. Charge of a proton, 1.6 times 10 to the minus 19 coulombs, 600 Newton per coulomb field, 9.6 times 10 to the minus 17 newtons then. Alright, the next step would be to find the acceleration of the proton, assuming that that force is the only force on the proton, so it's also the net force. To do that, I would use Newton's second law. A equals F net over M. So we'll have 9.6 times 10 to the minus 17 divided by our mass of a proton, which is 1.67 times 10 to the minus 27 kilograms. Looks like our acceleration is 5.75 times 10 to the 10 meters per second squared.